Welcome back. How'd you go? In the last video, I issued you the challenge to turn our datasets into data loaders. So let's do that together now. I hope you gave it a shot. That's the best way to practice. So turn loaded images into data loaders. So we're still adhering to our PyTorch workflow here. We've got a custom dataset. We found a way to turn it into tensors in the form of datasets. And now we're going to turn it into a data loader so we can turn our datasets into iterables or batchify our data. So let's write down here, a data loader is going to help us turn our data sets into iterables. And we can customize the batch size, write this down, so our model can see batch size images at a time. So this is very important. As we touched on in the last section, computer vision, we create a batch size because if we had 100,000 images, chances are if they were all in one data set, there's 100,000 images in the Food 101 data set, we're only working with about 200. If we tried to load all 100,000 in one hit, chances are our hardware may run out of memory. And so that's why we batchify our images. So if we have a look at this, NVIDIA SMI, our GPU only has 16 gigabytes. I'm using a Tesla T4 right now. Well, it has about 15 gigabytes of memory. So if we tried to load 100,000 images into that, whilst also computing on them with a PyTorch model, potentially we're going to run out of memory and run into issues. So instead, we can turn them into a data loader so that our model looks at 32 images at a time and can leverage all of the memory that it has rather than running out of memory. So let's turn our train and test datasets into data loaders. Turn train and test datasets into data loaders. Now, this is not just for image data. This is for all kinds of data in PyTorch. Images, text, audio, you name it. So import data loader. Then we're going to create a train data loader. We're going to set it equal to data loader. We're going to pass in a data set. So let's set this to train data. Let's set the batch size. What should we set the batch size to? I'm going to come up here and set it as a capital variable. I'm going to use 32 because 32 is a good batch size. So we'll go 32, or actually, let's start small. Let's just start with a batch size of 1 and see what happens. Batch size 1. Number of workers. So this parameter is going to be, this is an important one. I potentially have covered it before, but I'm going to introduce it again. Is this going to be how many cores or how many CPU cores that is used to load your data? So the higher the better usually, and you can set this via OS CPU count, which will count how many CPUs your compute hardware has. So I'll just show you how this works. Import OS, and this is a Python OS module. We can do CPU count to find out how many CPUs our Google Colab instance has. Mine has 2. Your number may vary, but I believe most Colab instances have 2 CPUs. If you're running this on your local machine, you may have more. If you're running it on dedicated deep learning hardware, you may even have even more, right? So generally, if you set this to 1, it will use 1 CPU core, but if you set it to os.cpu count, it will use as many as possible. So we're just going to leave this as 1 right now. You can customize this to however you want. And I'm going to shuffle the training data because I don't want my model to recognize any order in the training data, so I'm going to mix it up. And then I'm going to create the test data loader. Data set equals test data, and batch size equals 1. Num workers, I'm going to set this to equal 1 as well. Again, you can customize each of these. They're hyperparameters to whatever you want. Number of workers, generally the more the better. And then I'm going to set shuffle equals false for the test data so that if we want to evaluate our models later on, our test data set is always in the same order. So now let's have a look at train data loader, see what happens, and test data loader. Wonderful. So we get 2 instances of torch_utils.data.dataloader, and now we can see if we can visualize something from the train data loader as well as the test data loader. Or actually, maybe we'll just visualize something from one of them so we're not just double handling everything. Do we get a length here? Wonderful. Because we're using a batch size of 1, our lengths of our data loaders are the same as our data sets. Now, of course, this would change if we set, we didn't even set this to the batch size parameter. Batch size. Let's come down here and do the same here. Batch size. So we'll watch this change. If we wanted to look at 32 images at a time, we definitely could do that. So now we have 8 batches because 225 divided by 32 equals roughly 8. And then 75 divided by 32 also equals roughly 3. And remember, these numbers are going to be rounded if there are some overlaps. So let's get rid of, we'll change this back to 1. And we'll keep that there. We'll get rid of these two. And let's see what it looks like to plot an image from our data loader. Or at least have a look at it. Check out the shapes. That's probably the most important point at this time. We've already plotted enough things. So let's iterate through our train data loader, and we'll grab the next one. We'll grab the image and the label, and we're going to print out here. So batch size will now be 1. You can change the batch size if you like. This is just, again, another way of getting familiar with the shapes of our data. So image shape. Let's go image.shape, and we're going to write down here, this shape is going to be batch size. This is what our data loader is going to add to our images. It's going to add a batch dimension. Color channels, height, width, and then print. Let's check out the label shape. Same thing with the labels. It's going to add a batch dimension. Label, and let's see what happens. Oh, we forgot the end of the bracket. Beautiful. So we've got image shape. Our label shape is only 1 because we have a batch size of 1. And so now we've got batch size 1, color channels 3, height, width. And if we change this to 32, what do you think is going to happen? We get a batch size of 32, still 3 color channels, still 64, and now we have 32 labels. So that means within each batch, we have 32 images, and we have 32 labels. We could use this with a model. I'm going to change this back to 1. And I think we've covered enough in terms of loading our data sets. How cool is this? We've come a long way. We've downloaded a custom data set. We've loaded it into a data set using image folder, turned it into tensors using our data transform, and now batchified our custom data set in data loaders. We've used these with models before. So if you wanted to, you could go right ahead and build a convolutional neural network to try and find patterns in our image tensors. But in the next video, let's pretend we didn't have this data loader, this image folder class available to us. How could we load our image data set so that it's compatible, like our image data set here? How could we replicate this image folder class so that we could use it with a data loader? Because data loader is part of Torch utils.data. You're going to see these everywhere. Let's pretend we didn't have the Torch vision.datasets image folder helper function. And we'll see in the next video how we can replicate that functionality. I'll see you there.